Hello, and welcome to the Axon Instruments webinar series. My name is Jeff Weber, and I'm the Product Manager for Electrophysiology at Molecular Devices. I'm very excited to introduce my colleague, Dr. Jeffrey Tang from Molecular Devices. Dr. Tang will be highlighting using the newly introduced Clampfit Advanced Analysis module in pCLAMP 11 and how you can use it to make your data analysis process faster, easier, and more precise. And now let's jump in with an introduction to our speaker, Dr. Jeffrey Tang, Senior Applications Scientist at Molecular Devices. Jeffrey has over 10 years of experience working with Axon Instruments. He has been pivotal in various product breakthroughs and improvements, including the development of hum silencer technology and pCLAMP 11. Jeffrey received his PhD degree in molecular physiology and biophysics from Vanderbilt University and held postdoc positions at UC Berkeley and UCSF. His research interests include investigating the modulation of calcium channels by metabotropic glutamate receptors, studying the role of NR2B containing NMDA receptors in alcohol addiction, and researching the mechanism of synaptic plasticity in striatum. And now I will turn it over to Jeffrey.
Thank you, Jeff, for the introduction, and good morning to everyone in the West Coast, and good afternoon to everyone in the East Coast. And as Jeff mentioned that I'm a part of the developing team for pCLAMP 11. I'm proud to share the function of the new features of Clampfit 11 to you all. So we launched pCLAMP 11 in November of last year. Well, it takes more than 10 years to launch pCLAMP 11. Although it is a small step from 10 to 11, I believe that this small step would bring a great benefit to all pCLAMP users. Now, let's get started to share the excitement now. And today, I will talk about how to speed up precise data measurements using the new Clampfit 11 Advanced module. Just in case some of you may have, to do experiment, you may need to leave earlier. So my presentation will last about 40 to 45 minutes. Just in case you may leave earlier, I just want to give you this take-home message. So pCLAMP 11 increased visibility for protocol generation so that you can do more experiment, you can see more scientific excitement, and you can get more data. And the second important take-home message is pCLAMP 11 saves tremendous time in data analysis so they can do faster and then see precisely and get more free time. Now, what is pCLAMP 11? So pCLAMP 11 built on the strong foundation of the pCLAMP 10 that includes the Clampex and Clampfit. And Clampex 10 and Clampfit 10 have a lot of nice features, such as the user list, sequencing keys, as some of you already use it, and also we have the event detection, stimulus file. Now, in pCLAMP 11, we add the following new features in Clampex 11 and also in the Clampfit 11. I will talk about these two features in the next couple of slides. Now, the goal, why we're doing that, is because we increase the protocol generation visibility and increase the time saving and increase the measurement accuracy. Now, this slide shows you the new features in Clampex 11. Now, I'm not going to talk about, this is only a slide we talk about the Clampex 11. Okay. In order to improve or increase the protocol generation visibility, now we enhance the protocol editor, in which we increase the epochs number to 50 epochs. We also allow you to copy and paste the parameter amongst epochs. We also increase the sweep duration in episodic stimulation mode. And one thing that I like is that now in the gap-free mode, now you can pre-program of the analog output, holding duration, and digital output in the gap-free mode. Now, we also improved the membrane test. Now, in pCLAMP 10, there's only when you open it, only one membrane test window will be open, but now you can open multiple membrane test windows. And also, the analog output control is independent among each channel. Now, this slide is our focus for today. In Clampfit 11, we add the following features. Now, I need to tell you that in Clampfit 11, we have two modules. The one I would like to recommend is all of you should upgrade it to this advanced module, because this advanced module contains the new event detection. For example, population spike search and action potential search. And we have the batch data analysis. This will save you a lot of time. We also increase the cursor pairs in Clampfit up to 25 cursor pairs. Now, the other module is called Clampfit Standard Module that does not have this new event detection and batch data analysis, but does have 25 pair cursor pairs. Now, let's talk about population spike search. Now, why are we doing this? What is the rationale? Now, a lot of time, a lot of customers ask, how do we measure the peak of the population spike precisely? Now, you can see here, this is population spike. The peak is here. Now, how do we measure the peak relative to this baseline or this baseline, right? And the second, how to measure the multiple peaks of population spike. In this data, in this tracer, you can see there's two peaks of the population spike. How do we measure at the same time? And also, people doing the pair pulse response, how do we measure the pair pulse response, the ratio of, between these two peaks? Now, in the population spike search, here's what you can measure. Okay, the right-hand side just show you a typical, real data of a population spike at multiple peaks. You can see the first peak and the second peak, and this is the fiber volume. And what you can measure is that you can measure the rise time and decay time, as well as the rise slope and decay slope. And sometimes in some population spike, you may be able to measure this portion of what we call the EPSP. You can measure the rise time and also the rise slope, and you can determine what percentages of the peak from peak. Okay. And in addition, we can also measure the peak. In here, as shown is here, is the Z amplitude, or the area under the curve, or the half wave, and all of these you can measure. Now, I think the best way is that I can show you some demonstration with some real population spike data. Now, I'm going to go to the Clampfit. Now, you can see here, there's two data here. I'm going to open this panel. It's population spike, and then we have the multiple peaks. Now, under the event detection, now you can see here the population spike search. You just click here, right? Now, and then sometime this panel will be floating around, but you can drag this one to put it to the left-hand side or go to the right-hand side. It's up to you. Now, in here, you can see the event finding tab and also the measurement. When you click here, you can see the measurement, as I showed you in the last slides, that you can check the rise time, decay time of this spike, or the field EPSP, you can measure for this one too. But in this demonstration, I just want to show you how we can, I'm interested to measure about the Z amplitude and the half time. Okay, you can check or uncheck for this one. And now we go back to the event finding. Now you need to define is the polarity of the event. In this case, is negative going. And then we have several fine-tuning. These are also for the fine-tuning. And then we can have several level marker. We have the upper level bound, upper bound, and we have the lower bound. So basically, you need to have these two levels that include the whole traces or the magnitude of the population spike. And then we also have some fine-tuning, ignore region, and the minimum amplitude as a kind of like as a fine-tuning. I'm going to show you later, okay? Because I want to show you without using them first, okay? And I can put, for example, I can put 0 here, okay? I don't use any fine-tuning, okay? And then you can have this one, you can see that how many traces. Now in this case, I have 30 traces. I move cursor 1 and 2, whatever. Now I just click OK. Yes. Now we can go one by one by doing this one. You can check this one, accept it. You can click this one. If you don't accept it, you can click this one, reject. Now, because I have 30 traces, now what I want to do is I can go this non-stop. Then you will see all the data will be here. Now I told you that I just want to measure the peak of this spike, the first peak and the second peak. So I don't want to measure those. Now I'm going to show you how I can use the fine-tuning to get rid of those. I go back to here. Now one thing I want to show you is that I can set up, the minimum advanced event duration. Now I know that from here, you can see here is like about 1 millivolt. I can put, for example, I can put 1.5 millivolt here. That means any event more than 1.5 millivolt will be rejected, okay? When I put this one that you can see here, I click OK, that I said restart again. Now you can see more cleaner here. In order for it to see, I should do this one so that you can see each switch one by one. Right. Okay. Now, but I still get something like here, right? But how can I do that? Okay, now, go back to here. I want to do some fine-tuning. Now, this one I would like to introduce is called what we call the ignore region. You check this one, that you have cursor 3 and 4. You can move 3 and 4 here. I want to add this between 3 and 4 as the ignore region. So you can see the dot red line here. That is the ignore region. Okay. Now you can click this one. You can move them to anywhere, or you can uncheck this one. You can move anywhere that you can assign another ignore region. For example, I increase this one. You increase this one and hit this one, then you have another ignore region here. Now, by doing this, now we can do this one again, hit OK, because I have at the ignore region here, hit OK, and restart. Now you can see the data is much cleaner here. I don't pick up anything here too. Now look at the data. The data will be in the result sheet. Now we can go this one. You can see clearly, right. Now I want to show you sweep by sweep, right. You can see here, so this is the first sweep. The first sweep, we don't have any amplitude here. Now we increase the sweep duration. Now at 5, sweep 5, sweep 6, that we see the event. Now in this case, in the sweep 6, we only have one spike. That's why in the event, second event, we don't see anything here. Now we check this one, go to 10. Now you can see we have 2 spikes here. Right, you can see here. Right, you can click this one. Now, this one. Okay, anyway, that you can see here, you can see the sweep. You can check this number, right? So there's one way that I show you how to fine tuning. Now I still can show you how we can fine tuning, right? The other one. Now let me go back to here. Is that sweet? Okay, now, the other one I want to share with you is that you can also, if I don't use this one, I put it 0. Now you see, some small event will coming in. Now, I want to introduce for you to this one is called event trigger. If you put the event trigger here, that means only the event across the trigger line will be counted. So at this point, you hit OK. Yes. Again, you can see only the spike, cross over across the trigger line will be counted, right? So I can share with you. Yeah. Very beautiful. Now, I also want to share with you is that you can modify the data, right? For example, in this 12. Now, if you don't want this data, what you can do is that click here. You can reject it or suppress it. Now, reject is the permanent. You will reject the data, this data permanently, or you can suppress. For example, I suppress this here. I hit OK. You can see when I click OK, this data will be disappear. Now, but if you want to bring the event back, you can go back to here, accept. The 12 will coming back here. Now remember, you can reject this data, but once you reject, the data will not come back. Okay. All right. So anyway, now, and again, I also want to show you one more thing is that before you do the search, you are able to modify the search parameter. Let's do it one more time. Like in here, okay. So let me, okay, put this up. Let's cancel again. Let me bring out all the traces here. Right. Now we go to here. Then we can remove all. You can remove all. Yes. Okay. Now let me put here. Okay. Let me hit OK. And we do it. Now, this one, you like it or not? Okay, here. Now, what happened is that you want to modify this one, click this one, and 6. Now, in here, you can have this called enable editing. You click this one. Now, you can put the cursor near to here that you can add the search parameter, okay? And then you can click this one, okay? Right, and then you can accept it, okay? Now you can go back to here. You can try one more time. Now you can click here. What I want is that I want to show you. You can change the time, right? So basically, you can change it. You can move it. Okay, so this is what I'm trying to show you how you can edit the event, during the search. Okay, let me pick this one. Okay, now the next data I want to share with you is that is how we can measure for the pair pulse. Okay, let me bring the data out. Is this one. We have this one. You can maximize the signal. Go to the population spike. Right. Now, sometimes if you see something happen here, it's not this one. What you need to do is that you just close all. Sorry. Just close off, and we open again. Sorry, just open here. Just open this one. And then you go to maximum signal. And then you go to population spike search. Yeah. All right. So how we can do do this pair pulse, measurement. Now I want to show you first how the pair pulse data looks like. Right, you can see here, and you can see the duration is changes, but I just want to measure the peak of the first spike. I want to measure the ratio between the first peak and this peak. Okay, how we can do it, right? It's very tough, but we can do it. Okay, now we just select all of them. Now the total is here. Okay, now again, I don't want to, you can remove all. Now the good thing is that about this population spike search, now this configuration will save the configuration you did in the previous one, but you can remove them all. Okay, you don't need them. Okay, now you can select again what is the outbound. Outbound is here, and the lower bound is here. This you can select. Okay. Now at this time I put 0 here. I did this one before. You can put 1.5 there. 1.5. Okay. Now click OK. Hit this one. Wow, beautiful. You can see here. I just want to let you see each sweep. Right. Very good data. Very good. Very good. Yeah, very good too. Right, very good. Yeah. So basically, is one way that you can. Let me bring up the whole data to you guys. You can have the result. Right. You can bring it to here. You can see the data. The first one, the first spike, the first peak, and the second peak too. Right. That's why you can do the pair pulse response. All right. Now, you can also do one more time for the fine-tuning by the other way. Like I told you that you can do this one. You can get the event trigger, right? Put it here, right? You put it here that because you want to measure only the largest spike here. Put it here, and then even though you don't do anything here, it is fine. And hit OK. And we do this one. Now you can see only the spike that across this first line will be calculated. Now you can see the data, and then the data also beautiful too. So right now I show you how we can use the population spike to measure, the peak of the amplitude of the half wave precisely. Okay. Now let's go back to our presentation. All right. I know some of you are very happy right now to see, wow, pCLAMP 11 have this nice population spike search. Now, not only for that, now we also have improved action potential search. Now, why we are doing this? Now, in the past 10 years, a lot of you ask me, how do I measure the action potential duration 90 of cardio action potential, right? But right now, it's available in pCLAMP 11. And how do I measure the peak to peak time on the change of the action potential? Okay, I want to see what's the peak time, as well as the amplitude changes, okay, in the train of action potential. And also we can measure the action potential, the threshold of action potential. We can estimate it for you, okay? Now, in the window, in the action potential search, you can see how we can measure. We can measure the amplitude. We can measure the area to APD that you customized 90 or 50. Or you can measure APD 10, 30, 50, and 90, or you can customize 70% or 39%, okay? And you can also measure for the rise time, decay time, rise slope, and decay slope. And like I said, you can also measure peak-to-peak frequency, peak-to-peak time, trend in amplitude per peak. That will be a trend for the trend of action potential. All right. Now, let's get back to the action potential search demo, the Clampfit. That's what you guys exciting about. I hope that this time the Clampfit 11 don't crash for me. Honestly speaking, when I tested yesterday, no crash at all, no crash, okay? But, you know, because we're doing the webinar, you know, I'm nervous. Clampfit 11 also nervous too, okay? All right, let's get back to, okay, let's quit event detection. Now I need to bring on my data, right? My favorite data, okay, open the data, go to the, here, action potential. Now the first one I want to bring up is this ventricular action potential. Right, it's very nice, right? Then what we need to do is that we need to bring out our action potential search, all right? In here, I showed you before, you can, all this measurement that you can check, and we also have some fine tuning, noise rejection, right? Because this beautiful action potential, I don't need to do this kind of the fine tuning. Okay, what I need to do is that this is the baseline. You put it here, baseline, and this is a trigger line. Trigger line. I know some of you are familiar with our threshold search. It's kind of a similar thing. You can put the trigger line here. You can also set the pre-trigger duration, right? Because this is a cardio action potential, you can put longer, okay, 150 millisecond, okay. Then you can put the full traces, or you can put cursor 1 and 2. It is fine. Okay, let's do it right now. I want to have the peak amplitude here. I want to have the APD 90. Okay, I also have the APD, 70. How about this? All right. Then we just click OK. Then again, you can click this one. Wow, fast. You can see, click the result here. You can see the APD. You can see the amplitude. You can see the APD 90. You can see APD 70. Yeah, so we can minimize this one. They allow you to see. So again, when you click this one, you can see that event. You can click this one, you can see that event. And again, you are able to modify them, change the state, suppress, or reject. Okay, all right? So clean data, nice, okay? Now let's get back to another one I want to show you. Now the next data I want to bring out is a current injection, the event. Open the data. Right from here, go to the second panel, maximum signal, and I'm interested to analyze this data. They just move the x-axis here. Now go to the event detection operations by search. No, sorry, action potential search. Right in here. Now at this point, I want to make it bigger right now, and also bring the cursor. You can see 1 and 2, okay, 1 and 2. And again, you have the baseline, put the baseline here, and then you have the trigger line here. Now, because in this kind of data, I'm interested to the frequency of the action potential, or the time between, peak to peak, and the frequency. Okay, so I'm interested to the peak amplitude versus to the baseline. And I may want to get, for example, APD 50 because there's action potential. And then I want to get the peak-to-peak frequency, time, change the amplitude per peak. Right, and that's it. So the region is 1 to 2. And because it's the neuronal action potential, I just put here 10 to 30. 10 for pre-trigger duration and 30 for post-trigger duration. And hit OK, and then continue non-stop search. Beautiful data here. We can bring out the data, result. Yep. You can get the data here, minimize this one. So you can see the data here. In the first traces, we only have two events. You see, 5, 1 and 2, only 2 events. You can see this one is highlighted. You can move this one. You click this one is highlighted. Then you go to the 6, we have 5 events. You can see here, 1, 2, 3, 4, 5. Now you can see here, because we are measuring for the change in the amplitude, so that the first spike, we don't have the data to compare. That's why you can see here, the first spike, the data is empty. All right. So we can see here with second traces, we have 5 events. In the 7 traces, trace 7, we have 60 events. Very beautiful here, change in amplitude, and the peak-to-peak frequency, and peak-to-peak time. All right. Now, I want to share with you another data. Is that we open the data? Is this one. Now, at this one, I want to measure, because I want to measure the after action potential, in here, right? After potential. So what we need to do is that in here we just have action potential search. Again, you move the baseline in here, and the trigger line is here. Now, because I want to measure for this potential too. So in here, you can check this one. Right, I don't need this one. I check after potential amplitude, and also after potential duration. I also want to measure the threshold at this point. I want to measure the threshold in here, this potential and duration. All right, now, at this point, I want to be the full traces, to full trace, and hit OK. Non-stop search. Then let us bring out the data, result. Right. Now the amplitude, we have this one. Okay. And if we don't get this one, let me do one more time. Maybe I need to do some fine tuning sometime. Okay. Let's go back to here. I did that. Oh, I see why that's not working. Because you can see here, I should make it this longer. Because the event duration shorter than here, that if I put here, then let me put 30. Let me put 150. Now you will see that the data look different, right? I'm glad that I show you, right? Because you can see here the event is shorter than the duration here. So now I increase the post-trigger duration. Now you can see here, hit OK, and we start it. And you can see here, now when you run it, now you can see the data result. Now, that is what I want, right? You can go back to here. You can see amplitude, APD 50, after potential amplitude. What I mean is that this number, and the after potential duration is from here to here, and you can also get the threshold potential. It's around here, 26, 25.5. All right. Yes, I think I've been showing you a lot of things, right, about action potential. Now, I think some of you, most of you will like it, right? I know some of you in the audience, you are studying the cardiac action potential, right? I think that's a nice feature. Now I want to go back to my presentation. Next one, I would like to say another hero feature is called batch data analysis. Now, why are we doing this? Why? Because we've been listening to all of you. How do I save the time for data analysis? And some of you said that I spend whole day or half day on Saturday to do the data analysis, to analyze the data acquired from Monday to Friday. And I want to get more free time. For what? I want to do more biking, or, hiking, or cooking, or I want to do more experiment, right? That I believe that will be the last choice that you want to do, right? Then that's what we have the batch data analysis. In the pCLAMP 10, if you analyze for 10 files, file 1 to file 10, if each file takes 5 minutes, that means it will take, 10 files take 50 minutes. A simple calculation. Now in the pCLAMP 11, now you can open 10 files at the same time, and you just do one time. 10 files take 5 times, and save you a lot of time that you can do something else, right? I believe that you agree that it's a wow feature, right? Now let me show you the demonstration, right, for that. Now let me close this one first. Okay, I think I've already closed it, right? Now, batch data analysis, you can find it under the Analysis tab, Batch Analysis in here. Right, so this is the batch data analysis window. Now, in here, I think today time is not too long. I'm not able to. I don't think I have time to go through all the detail, but I just want to do some demonstration to you, and I believe that you guys are smart enough to explore yourself to find, how well the batch data analysis it is. Now, first of all, when you open it, of course, there's no data here. What you need to do is that you can import the data file. You can import individual file or entire folder. Okay. Now, I already import the data in here. All right. So let's do some demonstration. Now, when I click this one, this is have 4 data file. It's beautiful IV study. Okay, current and voltage relationship, right? So I want to show you is that, I open the 4 files at the same time. Now, what I want to do, I want to plot the IV curve, for example, right? I just go to here, right? So first of all, what you need to do is that you can go to move the 3 and 4. You can do the baseline adjustment, right? You can go to here, analyze here, baseline adjustment. For example, 3 and 4, hit OK. Now you move to 1 here. You want to measure the IV plot, okay? IV curve. Click here, analyze current and voltage. Waveform in the cursor 1 and the signal in the cursor 1. Hit OK. Wow, you see? I have this data, the second data, third data, and fourth data. All data will show here. At the same time, you can analyze the 4 data. It's very nice IV curve here, right? Yes. Now, I want to do another demonstration to you, okay? Now, let's say here, I go over to here. Now, I want to measure for the peak to you guys. This is the data. I want to measure the peak amplitude. I just bring the cursor, 1 and 2, and then 3 and 4. I want to measure for the peak for the 4 data file. Now, at this point, I want to introduce the macro. You can create a macro. For example, I set the name, give a name to the macro, peak. Okay. Then what you can do is that you go to here, analysis, go to measurement, right? Now you can measure it for the peak. Now, like you said here, the cursor ranges is 3 to 4, and the baseline is 1 to 2. That you measure for the peak, just for the peak only right now, okay? And hit OK. Now you can see here. Now you can, at this point, you can save it. You stop this one. When you stop this one, you can go to analysis. You can see, expand this one. You save the peak. This is the peak macro. Now all the data point will show it to here. Now you click this data. I just want to show you the data. Now you have the start of the trace. You can see beautiful, right? In fact, actually, this is a LTP data. You can see this one, see this one, and see this one, and see this one. Beautiful, right? Now, since we macro it, we record the macro is a pit. Now, for example, now what happened is that tomorrow, tomorrow I also using the same protocol, I have more data file here. I open it. Now, at this point, you don't need to do anything. You just go to here, go to this macro pit, and then you just run it. Now, all the data point will be here. Right. Let me see one more time. Here, the time. Right. You can see here. So all the data point will be analyzed at the same time. Wow, I think that will save you a lot of time that you can go to the biking or cooking, right? I believe you agree with me. Then not only for that, you can also export this data. Export this data result to Excel file. You can export it as comma separated or Excel and hit OK. Okay. All the data is here, right? All right, so I think I successfully to show you the best data analysis. It worked, okay? You can save your time. I believe that you're convinced that by me that it does save your time, okay? Now, but I have a few important reminders to you guys. Is that Clampfit 11 needs the dongle to work with, okay? I know that people use the pCLAMP 9, pCLAMP 10. They do not need pCLAMP 10. Does not need the dongle, but Clampfit 11 need a dongle. So that when you order, you will receive a 2 dongle, one for the Clampex, one for the Clampfit. And then also reminded that download the pCLAMP 11 from our website, okay, from our website. And very important is that you have to follow the instruction in the Quick Start Guide to configure the batch analysis to set up the MDC file server. That is very important. If you have not set it up correctly, the batch data analysis cannot be installed, okay? So again, summary. So this summary again is that I believe that I convince you that pCLAMP 11 increased the feasibility for protocol generation so that you can do more and observe more scientific, excitement and get more data. And again, the pCLAMP 11 also saves the time for data analysis. You can do faster and observe precisely and get more free time, to biking, cooking, and do more experiment. Now, this slide just to summarize that the model, I talk about the model that we have. You have the Clampex 11 standard, and the Clampex 11 standard, you have all the new features in the Clampex, but only 25 cursor pair in the Clampfit. If you order the Clampex 11 Advanced, you have all these new features in Clampex and Clampfit. And then we also offer a separated. You can also order for Clampfit 11 Advanced that you will only receive the 1 dongle for analysis only. So I believe that just like me, I like pCLAMP 11 and you too. And how do I upgrade to pCLAMP 11? Please write on this email address. You can email to om@modef.com. And then if I have more further questions for pCLAMP 11, now you can submit your question to support@modef.com. Then I would like to thank you, everyone.